You know how some AI can suddenly understand your private documents or remember a conversation you had last week? Well, behind a lot of that magic is a piece of tech called a vector database. And one of the most popular ones out there for developers right now is Chroma. So let's get into it.
So here's the fundamental issue we're trying to solve. We've got these incredibly powerful large language models, LLMs, right? But here's the catch. They have awful short-term memory, and they have absolutely no built-in knowledge of your specific private world.
So in this explainer, we're going to break it all down. We'll start with that exact memory problem. Then we'll define what Chroma is and see how it fixes things. After that, we'll dive into how it works, why so many developers choose it, and finally, what all this really means for the future of AI. Okay, let's kick things off with a big challenge that faces pretty much every modern AI application. Just think about it for a second. A model like GPT-4, it's trained on this huge public slice of the internet. It knows nothing about your company's internal wiki, your personal notes, or your project files. And that memory gap is exactly what stops an AI from being a truly useful personalized assistant. And this is where our star player comes in. Chroma is the technology that's built to solve this exact memory problem.
Now, I know that sounds a little technical, but the core idea is actually pretty simple. Chroma is a special kind of database built just for AI. It doesn't store things in neat rows and columns. Instead, it stores what are called embeddings, which are really just long lists of numbers that act like a digital fingerprint for the meaning of your data, whether that's text, images, or even audio.
So, the easiest way to think about it is this. Chroma acts as the long-term memory for your AI. It's the part that gives a language model the power to recall and actually understand your specific information whenever it's needed.
So how does Chroma actually solve the memory problem? Well, it does it by enabling this really clever technique called Retrieval-Augmented Generation, or RAG for short.
And this is a total game changer. Instead of the AI just trying to guess an answer from its pre-trained knowledge, it takes a crucial first step. It goes to a database like Chroma, pulls out the most relevant bits of info related to your question, and then uses that context to generate a way more accurate and informed answer.
So this process nails three huge problems at once. First, it gives the AI a working memory. Second, it shifts search from simple keywords to what we call semantic search. It looks for the meaning behind your words. So let's say a user asks a chatbot about a billing error. The bot can search your internal documents and find the section on invoice problems, because Chroma knows those two phrases mean the same thing. And finally, for developers, it just plugs right into popular tools they're already using, like LangChain. It's seamless.
All right, let's pull back the curtain and see how this all actually happens. How does your data get into Chroma and then back out to the AI? It's a pretty straightforward four-step journey. We're going to walk through each of these four stages, creating that numerical representation, storing it, searching for it, and then finally feeding it to the language model. Let's start with step 1. Okay, this is where the magic really begins. You take some kind of unstructured data, like a sentence, and you feed it to an embedding model. That model's entire job is to turn that text into a vector, that list of numbers we talked about. This vector is what numerically captures the real meaning of the sentence. Once you have all these vectors, Chroma stores them. It keeps things organized using collections, which you can basically just think of as folders. So you might have one collection for your company's FAQs, another for your code library. You get the idea. It's a really simple way to keep your data straight. Now for the really cool part, retrieval. When a user asks a question, that question also gets turned into a vector using the very same model. Chroma then takes that query vector and compares it to all the vectors it has stored. But remember, it's not looking for keyword matches. It's doing some quick math to find the vectors that are closest to it, which means they are the most similar in actual meaning. And here we have the final crucial step. The most relevant pieces of information that Chroma found are all bundled up and sent to the LLM, right alongside the original question. Now, the LLM has all the context it needs to give an answer that's accurate, specific, and, most importantly, grounded in your actual data. Okay, so we know what Chroma is and how it works, but you might be thinking, there are other vector databases out there, right? So why is Chroma so incredibly popular, especially with developers who are just getting started? Well, its appeal really comes down to this list right here. And the number one reason is just simplicity. I mean, you can get a powerful semantic search engine up and running in fewer than 10 lines of code. It's fast, it works with all the major AI frameworks, and maybe best of all, it is completely open source and free to use. This comparison table really shows where Chroma fits in.
If you just look at that setup row, you can see Chroma is by far the easiest to get started with. While databases like Weaviate and Milvus are these massive engines built for huge enterprise-level jobs, Chroma really owns that sweet spot of prototyping, RAG development, and small to medium-scale apps.
So, it really just comes down to using the right tool for the right job. If you're a developer, a student, or a startup, and you want to quickly add memory to your AI application without a ton of hassle, well, Chroma is pretty much the default choice.
Let's just zoom out for a second. This kind of technology isn't just some niche tool for coders. It actually represents a fundamental shift in what artificial intelligence is capable of. This quote just nails it. For years, the big focus has been on making AI models that can learn from massive amounts of data. But real intelligence, whether it's human or artificial, also requires the ability to remember specific information at exactly the right time. That is the missing piece of the puzzle that Chroma and other vector databases provide.
And that really brings us to our final thought. With this memory problem getting solved, the barrier to creating a truly personal, context-aware AI is lower than it has ever been. We're talking about everything from assistants that know your entire project history to learning tools that adapt to your personal style. The possibilities are huge. So the real question I'll leave you with is this: what would you create?